If they're not thinking through how is this going to get used in work and how are we teaching people to use it to the best of their abilities and to take full advantage of it, but then everyone's just stumped. Like, okay, well, what would that look like? What does that education look like?
We sat down with Jakobi from Cohere. We spoke about enterprise AI, the economics of language models, and also the societal impacts of language models.
We are enterprise focused, and so there's a lot of extra product infrastructure and services that go around the model to deliver to enterprise. There are some general classes of capabilities that we are good at as a company, specifically RAG and tool use and multilingual. My middle son is having problems with his schooling at the moment, and part of me thinks, does it matter? Like, should he just be thinking creatively and just going and doing his own thing and finding his own way? Because it's so hard to know how traditional education, especially if you're learning facts, is going to be helpful at all, or even kind of like something that develops your analytic thinking, or something that develops, your medical knowledge, your creative skills, all of this is within range.
Nick, it's an honor to have you on MLSD. Can you introduce yourself?
Yes, hi, I'm Nick Jakobi. I'm the product lead for the modeling team. I've been here about a year, and I'm responsible for how our models get better for our users, the more producty aspects, how across all the kind of model capabilities and the ways in which our users interact with our models, they improve over time.
What's interesting about this to me is LLMs are a general technology, and it's quite weird to have a general product. Generally we kind of build abstractions, to do specific things. So what is the product and how is it, or products, and how is it differentiated?
It is hard to be differentiated when you have a general technology, because it turns out you can throw our model at any question and it'll do something sensible, and you can throw any other competitor model at the same question, it'll do something sensible. So then you end up with a kind of, okay, over the space of all possible questions, are we slightly better than competitor models on this type of question, on that type of question? And the answer is yes, from model to model. You can make those differentiations, but they're quite fleeting and they go away. And as models evolve and as we come up with new versions, we end up being a little better at this, a little bit worse than that. When we are worse at something, then we'll kind of double down on that and kind of put in a big effort to get better at the things we're worse at. So then we come up again. Having said that, there are some general classes of capabilities that we are good at as a company and kind of take special pride in. So they are specifically RAG, retrieval-augmented generation, and tool use, and multilingual are the ones that we're kind of really proud of. And then other capabilities we're good at and getting better at, and hope to be as proud of the other capabilities. But that's just in terms of model capabilities. In terms of the actual product, as in the product offering that Cohere offers, we are enterprise focused, and so there's a lot of kind of extra product infrastructure and services that go around the model to deliver to enterprise. So we have our wonderful forward deployed engineering team that goes in and works with customers to get our models up and running on their particular use cases, which is a differentiator. And our models are available on all of the clouds, so AWS, Google, Microsoft, Oracle. So wherever your company holds its data and has a private cloud, we can be there in your private cloud, which is a differentiator. And also we do private deploy. So the idea is that with that enterprise focus, we have models which we make sure are good from a capability point of view in all the ways that enterprises care about. And then we have tools and services around those models, which are all in service of enterprises.
I've got a startup. I go to AWS. They give me $150,000 of credits, and I build my application on AWS, and they know I'm not moving. And I'm not moving because it would be very expensive to move, and their platform, is differentiated. It's like a key and a lock. What are you guys doing around that?
So, good question and timely question. For us, it used to be the case that, well, until recently, our models just weren't as good as our competitors' models, and so that was the thing we were just focused on as a company and certainly as a modeling team, just getting the models as good or better than the competition. Now we are very much kind of up in the game, but then it goes back to your previous point about this technology is very general, and the ways in which you call models don't differ that much between models. You might have to do a little bit of prompt engineering, but to swap one model for another is fairly easy, depending on your other requirements. So if it's on-prem, for instance, then there aren't that many model providers for on-prem, and then swapping our on-prem model for a competitor's on-prem model is going to be hard, or a major piece of work. If you're in AWS, let's say, using Bedrock APIs, and so literally you're just changing, because the Bedrock API for us and the Bedrock API for someone else won't be that different. Even more so in Azure, by the way, where it's kind of OpenAI API by default, and we have to squeeze ourselves in there. So then it can literally be as simple as changing a YAML file to change the model. So on the actual model level, there is a token game which is really going to be won by the companies that have the deepest pockets and can kind of stay in there the longest and just go and go and go. We will continue to be in that game. We are funded to be in that game. But at the same time, there's kind of, in our company now, there's a growing amount of realization that we also need to be, all the infrastructure and the services and the big P product that we can put around the models becomes super important as well. So how can we package things up in ways which provide solutions to our customers, which are sticky or which are unique, and which, if they get it working with whatever they're trying to do with our models and services and infrastructure, then changing from our ecosystem to another, it becomes more of an ecosystem play, and changing from the Cohere AI ecosystem to another then becomes a complicated exercise. And why would you do it unless we're substantially behind in some way that you do it, but otherwise you just stick with what's working.
Yeah, but just to press you a little bit on this token game thing, that's is it a myth or not? And what I mean by that is so many folks are model agnostic, and they have like a little drop down. You can say, I'm going to have Command R today, and I'm going to have OpenAI tomorrow. And I have a sneaking suspicion that it's not as portable as we think. So let's say you've built a really complex application, of like agentic workflows and God knows what else. And these things, there's some serious engineering you need to apply to robustify these applications. And it seems to me that if you did swap the base model out, probably wouldn't work the same way.
It depends. So if you've got a very complicated application where you've done a lot of serious prompt engineering to get your application working, and that prompt engineering is kind of takes advantages of quirks in a model, so every model behaves slightly differently in response to different prompts. So, you'll try a prompt, the model will kind of work, you'll try another prompt, and then, it is working, but then that prompt won't necessarily work in the next model, or it might do, even for something that's just purely using the model. In terms of prompt engineering, I mean, certainly if you're fine-tuning, you'd have to then fine-tune the other model. But if it's prompt engineering, yes, you are likely to have to do more prompt engineering. So it won't just be swapping the drop down. You're likely to have to re-engineer the prompts. But again, it depends. If you are using more powerful models and your prompts are well specified in terms of exactly what you want the model to do, then a more powerful model which follows instructions equally should be able to do the same thing. You might get slight stylistic changes, but if you're really specific about exactly how you want the model to respond and kind of you want it to do a complicated JSON with lots of different fields, and we have length specifications for each of the field and exactly what content needs to be in each, these type of things. And we run across quite a few examples of that. Commonly, that's how models are used in SaaS software to add kind of generative AI sugar, as I call it, to SaaS software. Then you need to get very specific about what you want the model to do. And then if another model is powerful enough, it should also be able to do that.
We are building all of these kind of APIs, controllers, prompt injection, applications on the top. And we think of them as being quite decoupled from the language model. And maybe in the future, when the models become really general, then we can think of them as being decoupled. But that's not really a reality yet. So we need to do lots of engineering on the top. When we upgrade the model, we need to kind of test our entire, life cycle and test all of our prompts and test everything is working correctly.
Well, so I think of it as the model, which has kind of been trained to be generally good at instructions, and everybody does some of that. Then you have kind of API calls, so like RAG, tool use, these type of things, where effectively what's happening is that the API is using specific prompts under the hood, and we've done a whole load of intricate data collection and fine-tuning the model to be really, really good at those particular prompts. And so that's kind of one layer higher level, I would say, than just the generic model behavior. So then if our APIs, we train our model to be able to do certain things in our APIs, most models have similar APIs or similar ways of doing the same things. But it's interesting to think whether there will be divergence there. It's not that hard to kind of copy what other people are doing. I mean, it is hard, obviously, but it's there's nothing that prevents other companies from copying what you're doing. So if they see your API does something, they can think, oh, that's a good idea, we'll do something similar. And then they have to do the hard job of going and assembling the data and assembling the evaluations and training the model. And none of that is trivial, but there's nothing that kind of stops everyone kind of continuing to compete on these different capabilities.
Yeah, really interesting. So, I mean, you've seen behind the curtains. I mean, you know how these things are trained and how they work. I'm interested in your mental reference frame, how you understand the behavior of large language models.
So on the product team, of course, we get lots of issues reported to us. So, a client tried such and such and the model didn't work. And, a large part of our job is to be able to kind of understand that, aggregate it with all the other things that are coming in, and then pick out the kind of failure mode or capability that needs improving, and then work with the modeling teams to generate the data and the evaluation to improve the model in that, to solve that failure mode or improve in that capability. And then getting the level right on that is a real art. So, if it's just one example, clearly you don't, I mean, what you can do, and we do is like, we get a prompt and it's doing something completely weird. We will just kind of show the model what the correct thing to do in response to that prompt is, but it might not learn anything general from that. So if you can spot patterns of things going wrong, and general behaviors that are going to be important for everything, you can create special data sets for that.
who knows, if we spend another 10x or 100x, maybe we'll move the needle. But, my kind of naive take on it, at least, is that it feels like it's saturating, and there might be economic pressures behind that as well. And we're trying to build smaller models anyway. I mean, at some point we haven't got enough money to keep, doing inferencing at the scale. But do you think it will get to a point where it's just good enough, like the iPhone 15?
I think we're already at a point where it's good enough. The way I think about it is, you have these small, amazingly powerful, 7 billion parameter models. They're good for some things. They can be fine-tuned to do some quite powerful things. More importantly, they're very cheap and they're very fast and kind of low latency. And the narrower the use case, the more you can train the model. So some of the code completion models are even smaller than that and faster, because they just do this one thing, which is kind of like take half your coding block and then suggest what else it could be. And latency becomes the most important thing there. So those models, although they're tiny, they are perfectly formed for that use case. Then as you go up, our 35B model and our 103B, so this is R and R+, we find that some of our biggest customers prefer Command R to Command R+, because it works. And so why would you use R+? It's just bigger and slower and more expensive. And really, I think that kind of the algorithm that customers run is they have a use case, they have a problem. Look at all these models out here, some bigger, some more confusing. Clearly, they need a model that can solve the use case for them. So it needs to be high enough IQ, but there's no point in paying for more than you need. And it needs to be fast enough to solve the use case. And if the model's too big, it'll be too slow. So you kind of go up the IQ until you get to a point where okay, that one is good enough, and then there's no point in going more. So it's interesting to speculate. We have our Command R, we have Command R+, which is higher IQ, slower, more expensive. Then there are much bigger models out there, GPT-4, Claude Opus, all of these things. They're higher IQ again. They're like 3-5 times the price of R+. They're much slower. They're too slow for many use cases. You can't wait seconds for this thing to come back. But there are definitely use cases where you need something of that kind of power around. What are the use cases that are unlocked by a GPT-5 type model? I don't know. Interesting to speculate. But the question is, like, if you have all these models kind of lined up, so from smaller to bigger, and then you've got all of the customers running the algorithm, I said, which is like, use the smallest model that works for you, the smallest, cheapest model that works for you. Then it's going to be really interesting in about 5 years' time, or maybe even 1 year's time, to plot like spend over model size. I suspect we will see the most spend or the most usage, let's say, because the bigger models are more expensive. So that, of course, needs to be taken into account. But the most usage around the kind of Command R, which is kind of GPT 3.5, Claude Haiku type of level. I expect that's the sweet spot. There's also a whole load of use cases which will be in the kind of Claude Sonnet, Command R+ niche there. And then I think it starts to, GPT-4 and Claude Opus get a lot of usage, but mainly for training smaller models and creating training data for smaller models and that type of thing. Obviously they're used for very mission critical, cognitively demanding tasks where you need accuracy and lack of hallucination and all those things, but they are expensive and they are slow.
Yeah, eloquently put. And at some point, the economics of it come into play. And I think we're really going to see that playing out.
Yeah, I think there will be two kind of thrusts. The whole industry has been driven up until recently by how high IQ can your model be? Like how cognitively powerful can you make your model? And the leaders in the space are the ones with the biggest, most powerful models. But I think we're really starting to see, as people start to put generative AI into production, we are starting to see cost and latency and these things becoming more important. So then if you can get that kind of GPT 3.5 Command R kind of level, if you can get that cheaper with lower latency, with higher throughput, like that is just as hard and demanding a research direction, and just as technically hard to make that happen. But it may end up actually being the most commercially profitable direction to go in.
Yeah, 100%.
On the absolute abilities, large percentage of use cases and questions and types of questions you can ask these models, the medium-sized models and the very large models will give equally good answers. And so you start having to ask these very complicated, involved, cognitively demanding type questions to really pull them apart. And then on something like Chatbot Arena, most people won't be asking those questions. They won't know how to ask those questions.
Exactly.
And then so then you're just getting into a whole load of personal preference that I prefer that one, which is ultimately just noise.
Yeah.
And then so I'm sure we're getting into that, because that is only as useful as the questions that get put into Chatbot Arena. And it's like telling apart the best mathematicians in the country. Like if you give them a simple kind of 16-year-old test to do, they'll all get 100%. So you have to come up with these incredibly complicated, intricate questions to kind of tease apart their abilities. And because Chatbot Arena, most of the questions just come from the general public, you won't see that.
Yeah, so language models are just trained on data out there on the internet. So presumably its capabilities are too limited on just what's out there, unless you believe that they have some emergent reasoning which transcends the training data.
I think so. It depends. Not every company has access to that kind of data. So, OpenAI, ChatGPT, amazing consumer success. They have a large amount of prompt data that came in because of that, which has definitely given them an advantage, and that they've got armies of annotators sitting behind. So with all this kind of real world prompt data coming in, and it gets annotated and adding to training, and that gave them a kind of a good early start, I would say. And then GPT-4 is then used to create training data, and so a lot of these open source models that you see doing really well have been trained on GPT-4 data. So all the early llamas and all the alpacas and all of this. We do get data at Cohere. We get data from people interacting with our website and entering prompts and getting answers and telling us whether they're good or not. And we use that data, but it's actually very small compared to something like ChatGPT. And then our models get used on AWS and Google Cloud and Azure. And it's part of our USP, which is that your data stays your data, it stays in your cloud. So we don't actually get to see that data. So all of the kind of annotation and data generation we do, or the very large part of it, we're actually generating the data from scratch ourselves. So prompt, completion, preference pairs, whatever we're doing, we're generating from scratch one way or another a lot of the time. And that certainly allows us to avoid some of the biases, because we can really direct what we're generating. But at the same time, it's still humans doing it, and you still get human biases in. And then a lot of the biases to models just creep in from the pre-training.
Yeah. And
the pre-training is not really anybody interacting with the model. It's just entering all the information in the world that already pre-exists. As much as possible, and of course that all contains biases.
Yeah, interesting. We've got things like Microsoft Office, and we've got all of this software, and usually it's pretty fully baked. I mean, Google were famous, I suppose, for having things in perpetual beta, back about 20 years ago. But it feels like language models were thrust on the general public, and I mean, maybe it's just a new norm, but sometimes they get things wrong. And now we're kind of saying to people, don't, always check the answers. And obviously you've done RAG and stuff like that, but it kind of feels like they're being developed in a very open way.
Yeah, I mean, this is the biggest experiment that's ever been run. Yeah, I think I'm right in saying that ChatGPT usage is the fastest growing technology, or the fastest adopted technology of any technology ever, by a factor of like 10 or more. Because even mobile phones, although everybody wanted one, there's kind of a real bottleneck around producing mobile phones and selling them out. But with generative AI, and not just ChatGPT, but suddenly it could get switched on in every single Microsoft application around the planet, and Google Docs all around the planet, and Bing and Google Search, and all of a sudden generative AI, boom, just becomes accessible to everybody. I would say within the space of 6 months, but probably less. From hardly anybody to the majority of kind of computer users around, and mobile phone users around the planet.
Yeah, interesting. So on AI safety, now there are loads of huge concerns. I mean, I've got some written down here. So things like enfeeblement, taking jobs, malicious use, concentration of power, bioterrorism. Like changing our relationship with technology, cultural risks in organization, the erosion of our agency, things like bias and fairness, automated warfare, persuasion, and also some of the more esoteric agential risks. So people talk about existential AI and stuff like that. And this is a really difficult line to walk, because there's, some people say, oh, this is paternalism, and some folks are utilitarians and consequentialists, and they're kind of thinking, well, I can tell the future, and I know that if you use these things, then bad things are going to happen. Therefore, I don't want you to do it. Versus some people who say, well, we can't predict the future, and we should be free. We should use the models however we want to use them. How do you think about AI safety?
I mean, I think so. AI and generative AI are clearly changing the world, and it's interesting to think how they will change the world. It's interesting to think how they will change the world of work, especially. We can already see it. Every single SaaS software, everyone uses SaaS software. Every company uses SaaS. So everyone uses tools, personal productivity tools, Google Docs, Microsoft Office, calendars, all of these sorts of things. All of these things are just going to get better and more powerful, and each person is just going to be able to do more, is how I see it. And so if you've got a job now, you're probably pretty good, because you'll just be able to do more, and you won't necessarily get paid more, but you'll be able to do more. I do worry that it means that the number of people needed to do any particular thing becomes less. The number of people who want to do things remains the same. And so I do worry, even kind of how education works now and the type of ways in which we're teaching people. It's so hard to know where to go and what's happened. I spoke at this conference it was all these business school professors, and there were all these professors who ran business schools. So there was INSEAD and UCL and LSE, and all of these places were there. And it was really a kind of conference to just get together and just like, what are we doing about generative AI? How is it going to change everything? What are we going to do? And half the conference was about how do we stop people from cheating? How do we stop students from using it? How do we as professors use it in the right way and not in the wrong way, and all of these kind of things. But then the discussion quickly went to the fact that, might be able to hold back the tide maybe 6 months. But then, of course, everyone's going to be using it. And certainly as business schools, the business school professors need to think through, if they're not thinking through, how is this going to get used in work? And how are we teaching people to use it to the best of their abilities and to take full advantage of it? But then everyone's just stumped. Like, okay, well, what would that look like? What does that education look like? I have 3 sons. My middle son is having problems with his schooling at the moment. And I go backwards and forwards. Part of me thinks, this is terrible. He's not as advancing as fast as one would hope. And part of me thinks, does it matter? Are there should he just be thinking creatively and just going and doing his own thing and finding his own way? Because it's so hard to know how traditional education, especially if you're learning facts,
Yeah.
is going to be helpful at all, or even kind of like something that develops your analytic thinking, or something that develops, your medical knowledge, your creative skills, all of this is within range.
Yeah, it's so true. But the culture in a business, the operating system in a business is quite mimetic. The way we share knowledge is, through quite a physical process. And that's still a bottleneck. So even though the language models generate things for us, you still need to understand it. You still need to kind of, filtrate that and diffuse it to everyone else in the business. And also there are many kind of planes that are currently outside the domain of generative AI. So, we have a real emotional presence right now. There's something beyond the domain of which is captured with AI. So I think there's still, a huge need for humans in the workforce, but it's so difficult to predict where it's going to go.
Yeah, I mean, absolutely. Not going to be anything sudden. As I say, I think just the productivity tools will get better and better. So you will need less people to do the same thing, I think. And then some domains will just completely just be automated. So I think radiography is one of them. For instance, looking at X-rays and working out whether there's a tumor there or not.
Well, on that though, Hinton famously said in 5 years there'll be no radiologists, and apparently there are more now than ever before. Jan LeCun put a tweet out the other day, and he said, "Well, where's the misinformation problem? Where's all of this harm people have been talking about it? I can't see anything." And that's quite a difficult thing to react to, isn't it? Because it happens so slowly and so perniciously over time. So this might be something that we can't see now, but we look back on in 50 years' time and we think, oh my God, this was a huge thing.
Yeah, and I think it's there's always been fake news. There's always been people lying on the internet ever since the internet. Now it's about the quantity and the quality of that fake news, and the fact that the actual people in the system, the accounts you're interacting with aren't necessarily people at all. And so now it's possible to, spin up 100,000 people, all with a certain political view, who then interact with everybody else and convince them. There's new and interesting ways in which AI can be used to pervert the natural course of things.
Yeah, exactly.
But I also agree. It's very non-trivial to understand if it's going on, and it by its very nature, it will appear, if it's successful, it will appear like it's not going on.
Yeah.
If you can spot it, it's not working.
Yeah, it's so true. I mean, for me, the big bright line, because I like ripping into some of the X-risk people, but for me, the bright line is agency. If these models really do have agency, which means they can actually set their own goals, and they can kind of that they can act and understand and make the world like their preferences and be completely autonomous, that throws an entirely different complexion on the matter. Because without agency, they're just tools. And ultimately, we're still the bottleneck. If we ever transcend the agency gap, I think that throws an entirely different complexion on the matter. And I'm glad people are thinking about it philosophically. But anyway, Nick, we're at time. This has been a fascinating conversation. Thank you so much for coming on. I really appreciate it.
Very welcome. You're very welcome.
Amazing. Well, there you go. That was wonderful.
Thank you.